Hello, everybody. Welcome to the second workshop, actually, in this Polkadot Hackathon North America edition. Today, what we're going to do, yesterday, actually, what we did was to look at Polkadot from a little bit of a higher level, higher perspective, what it is, how it functions, the architecture, and some of its components. And if you've been here and if you've been around, you would know that Polkadot is actually built with a blockchain building framework called Substrate. And today's workshop is really all about Substrate. Sasha, our colleague at Parity Technologies, is going to take you through what Substrate is, how it functions, all the nitty-gritty. But I think this is not a coding session per se. So I think this is going to be more of a higher level, introducing Substrate and how you can get started with it. But before we go to Sasha, Justin, please take it away. Justin's going to take a couple of minutes just to walk you through the hackathon, introduce some of the key concepts, as well as introduce the hacker guide, the registration process, and so on. If there's any questions, we're very happy to take them. You have a question box dubbed Ask a Question, and feel free to use that. We're going to get to it as soon as we can. And yeah, with that, Justin, take it away.
Right. Thanks, Urban, for the quick introduction, and welcome everyone. Thank you for taking time to join us in today's session. Before I pass the time to Sasha, I'm just going to quickly go through basically some of the hackathon information. So if you have not already known, this is basically the next stop of the global series, which Polkadot has been running since last year. And we are right now heading to the North American region. And while this is North American, similarly as the APAC edition, everyone across the globe is welcome to participate. If you have your mobile phone with you, you can just kind of grab and scan the QR code. You do have opportunity to do so later on as well. But essentially, this time around, we're trying to do things a little bit differently. We are kind of broadening basically what you can build and submit for the hackathon. And for the categories that you can participate, basically there's 5. They are not ranked in any sequence, but just going to go through very briefly. First of all, it's really on working on interfaces and experiences. Next is any ideas on DAO and governments. You are welcome to submit any submissions under this category. The third one, Web3 and tooling, is something that's a little bit more broad covering, where if you don't find that it kind of matches any of the other categories that you are kind of building your project for, you can actually submit them under the Web3 and tooling category. Next, other 2 are pretty much something that has been talked of the town for quite a while, which is DeFi and NFTs. So these are just some main categories that you can build your project submission for. This time around, we also have included quite a number of ecosystem teams who have actually put up challenges that you can integrate into your main submission that you are working on for the hackathon. What we're trying to do here is really for you to explore the endless possibilities by having a mix and match of either one or more ecosystem team challenges together, integrated to the main category that you are kind of building the submission for. So as of now, we have 17 ecosystem teams. What I want to really call is that there is one particular one that is with Subquery, Moonbeam, Akala, and Hydra DX, where they have combined together to kind of provide a bounty challenge that you can participate as well. So we have a huge prize pool of $613,000 as of today. And one part of it are actually funded by Polkadot Treasury, which is the category prizes. One overall winner will be walking away with 30,000 USD with Hackathon Swag Box and discount for Substrate Runtime Academy. And similarly, each category we will be awarding first, second, and third placing with 20,000, 15,000, and 10,000 respectively. On top of that, anyone who is participating, or your friends, family, and anyone else you know, do have the power to vote for a community choice. Essentially, anyone that is their favorite. We will be awarding 3 teams with the Community Choice Award, each team walking away with 5,000 in this case as well. Of course, apart from category prizes, we do have prizes that are awarded for each ecosystem team challenges. Information can be found on the participants guide, which I will briefly run you through later on. And similarly, you can reach out to any of the ecosystem teams folks that are actually on Polkadot Discord server under the Hackathon channel. So here are some of the upcoming sessions. The last part that got blocked out would actually be the mentor office hours. That's actually starting this Thursday, which is tomorrow. Essentially, the rest of the sessions are just to kind of quickly run you through some of the other introductory modules about the Polkadot ecosystem. And we do have a round two of networking and team formation happening tomorrow at 8 p.m. PST, 11 p.m. EDT, depending on where you are based at as well. So one of the interesting things that I just want to bring you across is that we are running a in-person hacker house that's going to take place in Brooklyn, New York City, in this location called Industry City. Similarly, if you have your mobile phone with you, you can scan the QR code and to kind of register your interest to join us in person. I've also dropped the registration link over there. You can click on to secure your seat. We do have limited number of seats at this point of time, so do leverage on this opportunity to actually register, and we will see you. The Hacker House is really a time where you get to meet the mentors in person. Sasha will be one of them actually, to kind of help you along in building your projects. And we do have workshops and lots of opportunity for you to network with different Polkadot team and ecosystem teams similarly as well. So there are two registration methods you can go ahead with. One is simply registering the QR code that you see on the screen. And I'm also dropping the URL on the chat box. But other than that, this hackathon, it's also, you can sign up via the dev post essentially. Basically, once you go to devpost.com, you can actually click the Polkadot Hackathon North American Edition. And you can click on Join Hackathon once you have went to the page as well. And we have lots of information up there as well. Once you are registered, top 3 things you need to do basically is to join the Polkadot Discord server. That's where we have a hackathon channel with all the necessary announcements and mentors up there to help you along. Similarly, we have prepared a hacker guide with comprehensive information that you need to know. And last but not least, the third one is to save a hackathon calendar to ensure that you don't miss out any of the hackathon workshops and mentor office hours that it's prepared for you. Quick overview on what you will get on participants guide, essentially all the way from the challenges to prizes. We have a checklist for you to know what you need to do as you move along in the hackathon. We do have mentors, submission requirements, judging criteria, all for you to review in order to help you to move along in terms of your building and just to make sure that you're on right track as well. Any contactable details are on there. My name is Justin, and I'm one of the contact person that you can reach out to. So I've completed all that I need to cover very, very quickly. I think it's time for me to pass the time to Sasha, who will run through an introduction to Substrate. Sasha, the floor is yours.
Hey guys, super stoked to be here. Justin, thank you so much for putting this together. This is a very special hackathon. This is the first of its kind because we're really kind of immersing ourselves in the ecosystem of different chains, of different technologies being developed within the Polkadot ecosystem. So I'm going to share my screen and I'm going to talk a little bit about Substrate. So for those of you watching live, as usual, you know the drill, ask your questions. This is an opportunity for you to have your questions answered in real time. I don't foresee this to be a kind of boring presentation from front to back. However, it could be, right? If you don't ask questions. What I mean is make the most of it. So I've done this type of presentation before, and there is a lot of resources already out there with what is Substrate, how can you get started with it. And so today I really wanted to make this more of an opportunity for people at the hackathon, people starting to maybe ideate on what they want to build, to understand how they can make the most of building with Substrate. So my name is Sasha Lansky. I'm developer advocate at Parity Technologies. That means that my job consists of trying to get the technologies being built in the organization I work for out to the world, out into the hands of you guys, of developers that are really going to be building the next coolest thing. So we just actually, Justin mentioned the fact that there is this really exciting event happening in New York City on the it's in the week of the 20th. Yeah, it's from the 23rd to the 28th of June. If you scan this QR code, you will be redirected to a Medium article more about that. And I will be present there. I would love to meet you guys. We have rare opportunities to do things in person, and this is one. So if you guys are around New York City, or if you are somewhere in the States, it would be really great to meet you there. So I briefly mentioned that I work for a company called Parity Technologies. And I like to kick things off to sort of lay the lay the foundations, or lay, you know, where do we come from the perspective of what is Substrate, right? So my goals today is to describe to you what Substrate is at a high level and how you can use it. And to start that, I think it's important to just understand that Substrate was created out of the implementation of the fourth blockchain client called Polkadot, the fourth blockchain client that Parity Technologies has implemented, which is Polkadot. So Parity is actually famous for the very first Rust Ethereum client that was built circa 2015, 16, and is still today the #1 Rust Ethereum client under the name of Open Ethereum. And then we kind of just went on and built a Bitcoin client and a Zcash client. So the takeaway here is we're a company who has a vast, deep experience in building blockchains, in building permissionless blockchains that are meant to be used by any piece of code, any application, permissionlessly. And I think that would at least set the scene for, okay, where are we at today with the tools that we want to empower you with? So if you look at a brief history, and there was a great talk by my colleague at the Web3 Foundation, Emre, who talked about Polkadot and pirate chains. But this progression helps also set the scene of what is Substrate. Bitcoin comes along. It's not intended to be programmable at all. It's got one purpose, and that is to implement this UTXO model, which is designed to manage coin spending. Then we kind of move on to this new era of permissionless blockchain infrastructure, where Ethereum comes along, and we are looking suddenly at the ability to program money, and we can actually go one step further than Bitcoin. And we have this thing we call an Ethereum virtual machine that allows us to program what we call smart contracts. And these smart contracts are, I would say, semi-programmable. I won't go too much into depth on what I mean by that, but however, we are still constrained to the EVM. And then from that progression, we now suddenly have this thing called Substrate, which allows us to build fully programmable blockchains. So a recap on Polkadot, it's a network to connect blockchains with security and interoperability. It is it introduces this new paradigm, right? This new way of thinking about the types of applications we're building. For these applications are multi-chain, and they completely flip the paradigm of having decentralized applications entirely governed by smart contracts, whereby now we are in this paradigm where each application, or you can think of it as each market vertical, right? If you are wanting to tackle the identity layer or some insurance market vertical, well, each market vertical really has its own chain, or each application has its own chain. And very important part of this talk in mentioning Polkadot is that it's built with Substrate. So I just saw a question come in, and I'm going to get to that when we go now into the actual substance of my presentation here. So yeah, today's plan, we're going to go through what Substrate is, what Substrate provides you, and how to customize a chain's runtime. And then we'll briefly look at things that have been built in the Substrate ecosystem and things that you could be building too, and finish with developer resources. Putting this in here because it's an idea I had and I haven't done it already. The actual definition from the Oxford Dictionary is substrate is an underlying substance or layer. It's defined as the surface of or material on or from which an organism lives, grows, or obtains its nourishment. And as the name suggests, substrate may be used to grow or build something on it. And in our case, we can build blockchains, or in the case of Polkadot, we can build a whole family of blockchains, right? Recall Emre's talk. We are introducing this multi-chain future where that already is up and running right now with parachains, right? There's a relay chain providing security for the chains connected to it. But we're not too involved with that. That's kind of very high level. We are going to dive into conceptually what Substrate is from an architectural point of view and from a technical point of view. Substrate is a generic blockchain development framework. It's written in Rust and WebAssembly, and it grew out of the Polkadot development framework. So we will be going briefly into what we mean by it's written in Rust and WebAssembly. But I do encourage you to ask your questions. I see that there's already one that we'll get to when we look at the architecture in a little more depth. So Substrate provides all of the core components of a blockchain. If you recall, or if you have been or have heard of people around in the days of the 2016, 17, and when all of these altcoins and alt Ethereum-like chains popped up, it was really hard to build your own blockchain from scratch, where the easiest thing to do would be to fork either Bitcoin, if that was the flavor of blockchain that you wanted to build, or Ethereum, if that was also the flavor of blockchain you wanted to build. You'd fork it and you'd make some minor tweaks to it, and you would call it, the Sasha blockchain, Sasha coin, or whatever it was. That's because it's actually really, really hard. So with Substrate is very unique because it actually, out of the box, gives you a database layer, networking layer, consensus engine, and a transaction queue. So these are really all of the core components necessary to build a blockchain, right? And what's incredibly unique with Substrate is that all these components are incredibly modular, and you can really extend them for your own use case. I'll add to that. You could implement all of these, but you'd then probably end up with a lot of bugs in your code. You'd probably end up with, vulnerabilities because they haven't been tested. This is all open source. These are battle-tested libraries that are available at your fingertips to build your own custom blockchains. And similarly, you'd need to implement cryptographic algorithms yourself. And very few people on this planet are actually cryptography experts. We are lucky to be piggybacking off of the research of the Web3 Foundation. So what Substrate does is that it provides us with a generic implementations of these typical algorithms, and it allows you to concentrate on the essence of what you're trying to build. And most of the time, which we'll visit in the context of what you could be building for this hackathon, this means the business logic of your blockchain. Right. My slide just added this, that Substrate provides you with a whole library to actually build out the business logic of your chain. So a Substrate node essentially looks like this in terms of its components, these core components that I just described. And hopefully, actually, this might answer your question. I'll ask Justin to click the link when I'm ready. I'm not quite there yet. So essentially, let's focus on the where it says the runtime storage. So the runtime is really it's the runtime of a Substrate chain. It's different than saying sort of the runtime of a gaming engine, right? But similarly, it's where the application specific logic of the blockchain lives, and that is compiled down to WebAssembly, and it's actually stored in the storage layer of the node and upgradable thanks to the fact that it's a simple Wasm blob. Then we have our sort of the client-facing side of this node, right? This node really is a runtime and a client, right? It's really sort of the runtime execution environment where the state transition function lives, and everything else that we can see in this diagram, which is the consensus layer, the networking layer, block production, that really all is the client code, right? Including the RPC server, how this node connects to the outside world, and telemetry likewise. So now actually, Justin, could you click the start answering question? So the role of WebAssembly, how does it play in Substrate parachain threads? So essentially, Justin, I'm not sure if you can hear me.
Yeah,
well,
I don't have the option to be able to click the answer part.
Oh, okay, yeah. So that's all right. That's completely fine. Well, WebAssembly here, JJ, the whole design of Substrate is that. Let's remember, the Substrate came out of Polkadot. When we were building Polkadot, we needed, and I invite you to read the white paper of Polkadot. We wanted to build a system that was upgradable and that could evolve. And the key design decision to address that is what we call in Substrate the Wasm runtime. WebAssembly is used in other things in Substrate. This is not the only use case of WebAssembly. For instance, it's used in the proof of validation for parachains, right? Parachains are producing blocks, and the way that the relay chain actually verifies this is by checking this Wasm blob, which is a proof of validation WebAssembly blob. Another key part of using WebAssembly in Substrate is the light client friendliness. So that Substrate is light client ready out of the box. And there's some really exciting workshops that we'll see throughout this hackathon, where we look at Substrate Connect. Substrate Connect is this JavaScript library that allows you to spin up a application with its own light client inside the application, and that uses WebAssembly. So it's in-browser light client node that it relies on WebAssembly for that. So getting back to it, this is like this high-level architectural diagram of what Substrate is. And there's this divide between the runtime, where as developers, adding and customizing the logic of our blockchain, we mostly live in, right? We would mostly be updating the runtime logic, right? The runtime code of our blockchain. However, there's all of this client-facing side with the libp2p networking, etc., consensus, where we can also be changing things on that layer too. So at a very high level, and this actually is adding to this what is WebAssembly and Substrate point, is that really a Substrate node, and when I say node, by the way, in blockchain, when we study peer-to-peer networks, any peer is a node, right? So a full node, for instance, in blockchain is a node that has all of the client-facing side, i.e., it can speak and share messages between peers of the network, and also it is running. In the case of a full node, it would be running the runtime logic of that chain, so that, for instance, if I'm an application, I can connect to it and have all of the storage items and metadata of that node as it is live and producing blocks. But it's a very high level here. A substrate node is a Wasm executor and a Wasm runtime. The Wasm runtime contains the runtime execution layer that we just saw here, and the Wasm executor contains all of the client execution layer. Is there any questions on what I just presented? Please feel free to ask if there is. So what do I actually get with Substrate? So I'm a developer. I'm really excited about introducing this technology into my application, or I've been wanting to build a Web3 application for a while. What do I really get with Substrate? You get future-proofness. Let's remind ourselves, out of the box, Substrate has to be a blockchain development framework that can build blockchains that can adapt over time. This is a key and core concept of Polkadot's vision. So we have this concept of hot upgradable chain runtime. And this means, for instance, instead of having a blockchain that would require a hard fork, like we've seen in numerous examples in the past of blockchains that have had to go through this, well, we have this ability through on-chain governance to propose a new runtime and upgrade it seamlessly. As part of your introduction to Substrate, guys, I strongly recommend you look through our tutorials, and you will actually be able to do this, exactly what I said, in a tutorial that would probably take you no more than 2 hours. What do you get with Substrate? You get interoperability. If you launch your own Substrate blockchain, you can connect it to a relay chain, whether it's a testnet relay chain like Rococo, or you could connect it to some other testnet that you create, or you could make your own crowd loan and become an actual parachain on Polkadot or Kusama. But out of the box, you get interchain connectivity by connecting to a chain like Polkadot. And this is very powerful, because this isn't bridges, right? Bridges have a lot of vulnerabilities, and there's a lot of really good work being done in bridges. However, the connection between blockchains that Polkadot, that Substrate chains can permit, if they are connected to Polkadot, this has never been seen before. There's similar technologies out there, but out of the box, you have the ability to have a chain-specific application that can piggyback or utilize really some other cool chain-specific application. For instance, there's some really great NFT projects in the Polkadot space who are, collaborating with other blockchains, other parachains in the Polkadot ecosystem, and this is really powerful. The last point here is you get light client support. Now, this is really, really powerful too. There's a workshop that's going to happen on June 14th, I believe, where a colleague of mine will be presenting Substrate Connect. And essentially, the takeaway here, guys, is if you are building a front-end application or user-facing application for some dApp or whatever, on any chain really today, the likeliness is that the end user will actually have to rely on a third-party node provider to connect to their application. It's really like saying like, hey, I have this really cool governance app that you can cast your votes, and it's blockchain and it's Web3, so it's completely permissionless and trustless. It's amazing. However, under the hood, you're actually relying on a third-party node provider, and this is in all user-facing applications that exist today, because it is much more efficient to rely on a third-party node provider, for instance, Infura, for the Ethereum world, than to run your full node, right? If you're an end user, you're not going to actually download the whole blockchain, run your full node to connect your application to that blockchain. It's much easier to just sort of trust the front end and let it connect to whatever third-party node provider. Substrate is built with light client support out of the box. That means if your front-end developers are building applications on top of your runtime, or are building applications to interact with the runtime logic of your blockchain, they are able to use a JavaScript library that spins up a light client node in the browser, such that your users will connect directly to that light client and will no longer need to rely on a third party. What else do you get with Substrate? You get this thing called Frame. It's really cool. It allows you to customize your runtime logic very easily. It's actually, this is a lot of code. It's a lot of complexity. There's a lot of overhead in writing logic that can just execute inside of this runtime and client-facing side paradigm that Substrate is based on, right? We'll look a little bit more into that when we go into palettes. Actually, there's some questions, so let's quickly look at that. Can you please explain a bit more about what is Wasm Executor and Runtime? So Alan is asking, can you please explain a little bit more about what the Wasm Executor and the Runtime is? So yeah, so you're referring to this right here. This is just a way from a very purist, high-level architectural point of view, what Substrate is, right? It's really built in a very modular way, such that the runtime, the business logic of your chain, is actually being executed in this Wasm environment, and that implies that the client execution layer is interacting with that Wasm environment. So ultimately, if you think of Substrate as very high level, there's all this client code, the networking, the consensus, and everything, and there's this runtime code. The runtime is a Wasm runtime, and the executor, i.e., block production and peering between nodes, is dealt on this Wasm executor layer. That's basically what what we mean by that. So Dagmar is asking, and Justin, if there's a possibility to have these questions linked to the moment I asked them, that would be really cool. So I'm asking you this question now. Can you give an example of existing cross-chain use of NFTs? I think at the end we'll give some examples. Perhaps we can look at something more specific by looking at Polkadot.js if we have time. There are so many different NFT projects, and things are moving at a very rapid pace with the latest development of XCM. And I have no guarantee of what I know today if that's the most updated. But I would, Dagmar, I would recommend that you just kind of look around at the different NFT projects being developed in the Polkadot ecosystem. I'm sure you'll find some interesting things. And please, would love for you to share. The next question is, can you give an example and explain the difference between West End and Rococo? Very simply, West End is it's a test network that has no economic value. that Parity was using for its own testing purposes. And now Rococo is actually much more than just that. It used to kind of be similar to that, but Rococo now is a community-owned. Well, Rococo today is Parity maintained, i.e., all the validators are being maintained by Parity. It is not economically bearing at all. There is no economic value in testing. It's really meant to be for parachain teams to test their runtime upgrades and everything. And a key unique selling proposition of Rococo is that it has the same runtime as Kusama, except that things are sped up. Like it's much faster, like the waiting times, the governance proposal times, and all that. So yeah, and the vision for Rococo, and there's a seminar on this that I can drop a link later on, or maybe Justin, you can drop a link on the seminar on Rococo, where we were talking about how Rococo is intended to be completely community owned, and how we were looking at what's the process in decentralizing that, going from pseudo governance to, well, democracy, basically. Cool. I hope that answered your question. Does XEM allow for Polkadot Kusama communication? The answer is right now. So Polkadot is a relay chain. Kusama is also a relay chain. The communication layer between relay chains really is done by bridges. I'm not an expert. So the quick answer is I would recommend you to read the docs of XEM. There's a lot of really great development happening there. XEM v3 is coming out, and that allows for, I think, what you're asking about. Okay, so I'll kind of move on with this. Where did we leave off? We left off at what do I get out of Substrate? So really, like, these are the key, really, really cool things that Substrate gives you. And at the very last point, there's this really neat way to develop runtimes. In fact, that's what Parity has been working on, putting incredible effort to make it really easy for developers who come from more of a smart contract world to write their own runtimes using Frame. And there's a bunch of palettes out there. We call palettes. We will be going into this in the next slide. I'm kind of getting ahead of myself, but we made it really easy to write these runtimes, and also other developers with their own languages can come and write their own runtimes if they wanted to. So there's more to the list here, actually. So Substrate provides this WebSocket JSON RPC node out of the box. It provides a transaction queue and secure networking layer using libp2p. And out of the box, like if you download, if you go to the Substrate node template and run your own node, you could launch your own telemetry server where you can see the validators in your node. You can see the different telemetry of your node, right? So that's also very powerful. If there's one thing I want you guys to take away from this intro to Substrate talk, is that Substrate is modular and extensible. And it really has been built that way from day one, where everything we've been talking about can kind of be summarized in this slide. So we've got really these three pieces, right? The client component, and then this Wasm runtime. And we have this thing called Frame, which allows us to write logic that can be compiled down to this Wasm runtime and executed by the blockchain node. So the client side consists of consensus, networking, and telemetry. The Wasm runtime is the state transition function of the blockchain. Very simple, right? Every blockchain has this concept of a state transition function, and the Wasm runtime is built to be highly efficient and generic, which allows you to do a whole bunch of things. So this is a screenshot of the what an example node would look like if you downloaded the Substrate node template. This is actually a screenshot from the contracts node, and at a very high level, you'll see this folder called node, and that has all the networking stuff, right? So this directly relates to what I'm talking about here at this top here. So the client code really is encapsulated in this node folder, and you'll also notice this palettes folder. So this palettes folder is where the code of the custom modules or programs really that you can compile into your Wasm runtime. And these palettes, we call them palettes because they're built with Frame, and Frame has its own way of making it possible for developers to do that. And at the very last, this very last piece I wanted to point out is this runtime folder. So in the runtime, that's where all of the palettes are compiled and used to execute the chain's logic. This workshop isn't doing any code demo or anything, but I do invite you to, again, just go through some tutorials that already exist on our developer hub. That's docs.substrate.io, and find the tutorials. You will immediately be immersed in this. The goal of this workshop is to show you kind of what it's all about. What are all these pieces about? Hopefully then you can jump into the repo and be more familiar with all of this code and what it looks like. In the beginning of my talk, we did kind of compare with what it used to be like to build your own blockchain in the past, where you didn't have all of this. The easiest thing would be to fork your own blockchain. And well, if you were to completely have your own have all the code of Ethereum into one repo, it would certainly not look like this. And really, this is owed to the power of crates in Rust. This is owed to the modularity by design, the engineering principles behind how this code base is organized. And the leap from that world to today is quite extraordinary, because suddenly we can have an entire blockchain that looks like this in your VS Code view, which is pretty powerful. So a little more deeper, right? So we had this kind of overview of the Wasm execution environment, where we had this Wasm runtime and all the client code, and now this actually looks this actually helps kind of go a little more into a visualization. And I realized that the screen is pretty bad, but I'm gonna share this screen instead. And so basically, give me 1 second. What I'm about to show you is a visualization of the crates and the different basically the code base of Substrate, and we're going to do a quick comparison of what it looks like next to Polkadots. Remember, Substrate is kind of has been abstracted out of Polkadot from day one of developing Polkadot, or the earlier days, and now it is actually just being used to continue the development of Polkadot. But they're two standalone code bases. So I'm going to have to do this and do this. Give me 1 sec. And I'm going to do this. So if you go to this link, actually, you'll see what we're looking at, and you'll be able to actually interact with it. Like, you can click on these things. But this is literally just the Substrate code base, where, remember we were talking about the client and the runtime. It's a shame that there's no arrows between these to show the dependencies. However, it does kind of depict what I'm trying to say is that all of this is organized in such a way that as developers, you're empowered to extend these libraries, to build on top of them, and to really reuse elements of them in a way that empowers the use case that you want to do. So probably most of you for this hackathon won't really be like messing around with a client-facing side of a Substrate node. However, it's really important as developers that are diving into Substrate to appreciate what Substrate really is and how it's been built. And so we're gonna. Can you see this? Yeah, you can. You can see my whole. Oh, that's amazing. This is what I needed. So right here is Polkadots, right? So if you look at Polkadot's repository, you can see that it's taken a lot of things from Substrate, right? We have the runtime. We have all of the bridges code. inside of the bridges code, we have all these primitives. And let's click real quick. These are primitives that have been developed specific for some bridge implementation in Polkadot. But going back, what's very interesting is that all of the networking layer of Polkadot lives within this folder structure. All of the runtime layer of Polkadot lives within this structure, and we can go even within each one here inside of the runtime. We've got Rococo, Kusama, Polkadot is here, and if I go to it's a cool visualization tool, but it's hard to know exactly where you need to go. But like right now, we're in the runtime of Polkadot, and this is what it looks like. So if I go real quick, construct run. So one of the things that you'll quickly learn if you do a tutorial is that the runtime, right? The Wasm compilation is actually done right here. So the first thing that happens when you build a Substrate node is that this runtime is hit. Sorry, this line of code is hit, and basically what you'll see that happens in the terminal, it takes a long time because all of these palettes are built. So we're looking at, I guess I can zoom in if you guys want to see this, but this is Polkadot's runtime. It's made of a bunch of basic stuff. It's made of the consensus layer, consensus support, which you can see here, and these are all palettes, right? These are all frame palettes. These are palettes that have been used using Substrate's frame. Substrate's one of Substrate's USPs, which is frame, which we looked at previously in my slide. And so it's actually kind of cool that you could think of how any blockchain built with Substrate is really using Substrate for its own use case. And so if you go back to visualizing its code base, and now do a quick comparison, like if you have good picture memory, just take a snapshot of that, and now look at that. So, right, this is the kitchen, and this is the product, right, the dish. In a way, I can't find it. I'm just thinking on my feet here, right? But if you appreciate Substrate, you appreciate the fact that when it's being used for a protocol implementation, that protocol may borrow things from Substrate and make its own thing with it. XEM, for example, is not a Substrate thing. XEM is part of the Polkadot protocol that has been developed using Substrate primitives. It has to adhere to the runtime and client model that we just looked at, right? However, it's its own thing. So like if I go into some of these primitives, you will notice that they are using let's see, a lot of things that so the concept of weight, for example, that's a Substrate concept. I mean, palette XEM. So XEM, again, is a Polkadot specific thing. What we're looking at, by the way, for those who maybe just jumped in, is just that Polkadot uses Substrate in its own way, right? So Substrate is this thing that can be used and implemented for its own use cases. So we can see that this create frame support is actually being used in this code base. That's what we mean when we say that Substrate is incredibly modular and extensible. It's really powerful in that way. Okay, cool. So back to my presentation. I guess I don't need to yeah, we can just continue like this. So if there's any questions, please feel free to ask them. So what's a chain's runtime? Well, a chain's runtime is the application-specific business logic of your chain, right? You can think of it, well, actually, it's really that. You know, a runtime has its storage items. A runtime has access to consensus. It has access to the fundamental, really the fundamental pillars of what makes your blockchain. And when you develop palettes for it, you have access to all of these things. So that makes it very different than smart contracts, right? And similarly, and I invite you to watch a talk I gave a couple weeks ago at the Chainlink Hackathon, where my audience was more smart contract audience. And so essentially I was leaning in more to give some analogies that smart contract native people would probably understand better, which basically is that with this paradigm of having a Wasm runtime, we can do so many more things. Let's qualify that though for the smart contract natives. We can actually implement our own virtual machine to execute smart contracts in our runtime. So really, we can have a palette that specializes in being a Ethereum virtual machine. And that's what any parachain that is compatible with the EVM, they actually have a palette called EVM. If I look at that EVM palette substrate. So yeah, so there's actually a bunch of this stuff in our docs, but essentially, if I scroll to the way bottom, I can probably find this EVM palette. So this EVM palette, it's literally like I was showing you. It's built with Frame. It gives you the ability to execute an Ethereum smart contract on a Substrate chain. So if you guys are interested, you can just look a little bit more into that code. Really, the interesting part is that Substrate it gives you so much more flexibility than smart contracts only. So yeah, let's get back to this. It's really where the chain your chain's business logic lives. And if that's smart contracts, that's great. If it's really heavy lifting and mission critical governance, pretty much like what one of Polkadot's key value propositions is, well, that's also doable or implementable at the runtime level. So what are frame palettes? Well, there are ways to simplify runtime development. They enable composability. When we were looking at Polkadot's runtime, you could see that there's a whole bunch of palettes that are really composing logic together, right? We have the concept of a scheduler palette that enables when there's a governance proposal for a proposal to be scheduled and executed on some given schedule. In that example, you have a palette that handles democracy and voting, and you have another palette that handles scheduling that proposal and enacting it. A palette also handles events and errors. Very similar to writing an Ethereum smart contract, right? There's similarities because your Ethereum smart contract is interacting with the EVM, which has a set of opcodes, and you need users to be able to access some function. Similarly, that function, when it does make a successful change in storage, well, it emits an event or it emits an error. The concept of dispatchables in Substrate is essentially a publicly permissionless function that can be accessed by anyone. So how does it work really at a high level? For those of you who have not sort of done a tutorial or anything, at a really high level, and assuming that you know a little bit of Rust, you have this concept of a configuration trait. It's a trait that specifies all of the things that your palette will need to be integrated into the runtime. Remember, this runtime compiles down to Wasm. It's then being executed by a Wasm executor, and that really is how the business logic of a substrate chain is executed. But however, it's not just any Wasm environment, right? It's a Wasm environment that is specialized to be to adhere to what's happening on the client and consensus layer too. So this configuration trait is common to all frame palettes, and it allows you to specify the specific parameters and the types on which your palette depends on. For example, you can have an NFT palette. Your NFT palette in its configuration trait will have a concept of balances or currency. It'll need to pass currency through the application logic of that palette, as well as a concept of accounts, a concept of deposits, and all of these kind of key things. But it could be other things, right? It could be passing in a constant value, for instance, that there's only some number of maximum NFTs of this type in existence, and that we maintain a constant value at the palette level that's really ingrained in the palette by using this configuration trait. So it also has this concept of storage and events and errors, right? So similarly to writing an Ethereum smart contract, where there's an interface that allows this palette to interact with the storage, the underlying storage layer of your blockchain, and emit events and errors accordingly. And finally, we have this concept of dispatchables. That just allows users to make calls into the runtime. Dispatchables really, it equates to making a transaction, right? So that transaction could be for governance. That transaction could be for sending some coin from one account to the other. I will actually lean in on one thing for those that are completely new here. Well, there's this concept of extrinsics in Substrate. So Substrate denominates any type of transaction that comes from outside of the runtime as an extrinsic. And that's because there's a little more interesting complexities and intricacies with the way that Substrate was built, trying to account for the different types of sort of, think of it as things that could change state in my blockchain, right? And that could be a transaction, but that could also be a block author that updates the state with the current timestamp, or that could be some internal logic that changes the state. So, for instance, an off-chain worker. So we have different types of quote-unquote transactions, but we call them extrinsics for that reason, because there's actually three types. There's signed transactions, which is more typical for any for sort of a transaction that's being done from the outside world permissionlessly. That's a signed transaction. There's unsigned transactions. That's really essentially transactions that, for example, a council member, if they have enough votes, they can execute a given proposal. That doesn't need to be a signed transaction the same way, right? However, that's still going to be understood by the runtime as something they need to handle as a as something that will change the state of the blockchain. So that's an unsigned transaction. And finally, there's this concept of an inherent, where it's specifically most widely used in block authoring, where every block needs to give the runtime a sense of the current timestamp is. So that's also some information that needs to be handled by the runtime. I invite you guys to read more of our docs, because this stuff is explained there in greater detail. So very high level here, a palette looks like this. I mean, this is a crunched down version of a palette, right? So you have the imports at the top, you have a configuration trait, and then this pub struct palette generic over T really is this instantiation of using these macros that power Frame. Frame is really, really powerful thanks to these macros, because essentially you're writing Rust code with this stuff. You don't need to be battling with some specific DSLE type syntax when you're writing your runtime code. At Parity, we've really tried and done our utmost best to make it as easy as possible for writing idiomatic Rust. So essentially, what you see here is all of these macros. So that's a hashtag palette semicolon storage, for example, and the macro just does a bunch of work in the back for you. So you don't need to bother with writing hundreds of more lines of code to instantiate your storage item. You can literally just instantiate it by using this like idiomatic Rust. So pub type something generic over T equals storage value, and just look up the API, and there's a bunch of different ways to interact with storage. That macro will know how to handle those different instances of storage. So similarly, we have that with events, with errors, and with palette calls. learning Rust is going to be a really, really useful thing if you dive deep into Substrate. Rust is a very powerful language, and not only like learning Rust for the purpose of being interested in blockchain development with Substrate, but really like learning Rust is an investment in your future at this point. The biggest companies out there are adopting Rust. We at Parity are really a Rust company. So I don't want to spend too long on this slide, but Rust is fast, right? So it's statically typed. It's compiled, meaning that it's possible that the compiler can optimize to the target architecture and and optimize the code for speed. So we compile down to Wasm, right? You'll notice if you do a tutorial, we use this Wasm Wasm unknown. This is the target for what we're telling the Rust compiler to compile down to. So that is incredibly powerful and useful for our use cases too. The compiler won't let you write unsafe code. That is true. When you're writing Rust code in any development framework, you'll spend most of your time battling the compiler. The compiler is your friend. The compiler will only let you get through the compilation if there is not a single buggy or potentially buggy error in your code. And Rust is memory safe. There's no garbage collector. And really the takeaway for Substrate is that Rust is Wasm first. As I said previously, most of Substrate is idiomatic Rust. You'll see that there's a bunch of macros. They're there just to abstract the complex logic and make it easy for you to write your runtime code. Added benefits: the community of Rust is incredible. We're also not, Rust gives us this amazing thing that we take for granted, which is there's a huge community and a huge backing of large corporations that are innovating with Rust. So we don't need to be inventing our own tools and whatnot to empower our developers. A lot of these are being developed and already exist. So if you compare that with like a language like Solidity, there's a lot more sort of legacy and heritage that we inherit with Rust. And Ferris is cute. Yes, it won't be too difficult, I promise, and it'll be worth it. You should learn Rust. So what's being built with Substrate? I'm going to kind of skip through this. Just scan the QR code. There's a lot of things being built with Substrate. There's so many things being built with Substrate. Really, this just shows that we have a lot of market verticals, right? So the market verticals of DeFi, different wallets, identity chains, social smart contract chains, they're there too. File storage, right? It's not all about building chains. We can have infrastructure using Substrate. What about arbitrage bots? That's a cool thing that you could build using Substrate and knowing the different tools out there to interact with Substrate runtimes. What can you build with Substrate? So there's a lot of things that can be done with Substrate, and I think Justin's been doing a really good job with advocating for the awesome hackathon that you guys are a part of today. There are countless prizes and bounties from parachain teams that are suggesting things that you could be building for their teams. There's also a bunch of resources that you could dive into, including documentation from teams that are doing their own thing with Substrate. So there's really a lot of things. The way that I kind of put it or think about it, or I want you guys to think about it, is in how these categories for this hackathon are laid out. So really, that's interfaces and experiences, DAO and governance, Web3 and tooling. So when we talk about tooling, it could just be using SubXT is actually developed by Parity to create client applications completely built in Rust. And there's so many opportunity for simple tools out there that could be really useful. And the fourth pillar really is DeFi. So decentralized finance being a really hot topic, but also an important one to get right. And NFTs. So the fifth pillar being NFTs. A lot of things there to be doing NFTs. The categories are there for you to look at, but I want to make the most of my time here. all of these are really great ideas, great starting points, depending on your background, depending on what you're interested in. But I think there's one thread between all of these categories, which is we're building for a multi-chain reality. That means that our mindset here is for developers, we need to build in such a way that our applications can be multi-chain and are future-proof in that way. But really for the end users, that we want our end users to feel this empowerment by being able to have sovereignty over their assets, over their digital assets and digital ownership axiom, sort of like pillars, like really why they would be here in the first place. For me, that's digital ownership, and for them to be completely empowered by moving around from chain to chain while maintaining decentralization and that digital ownership. So I think that's the coolest kind of thing that we could really have at the back of our minds here, building stuff with Substrate for this hackathon, especially, and you know, I think that will help you guys go a long way. One thing I want to highlight is user experience. So just if it's worth anything, we talked a lot about Substrate in terms of its architecture. We kind of dipped our toes into like more technicalities about what that architecture looks like, and really the design decisions in making it that way. We're gonna switch away from that and basically leave maybe some time for some more questions if there are any as we near the end here. But in switching away from what Substrate is at a high level and the architecture of a Substrate node and all of that, I want to shift our attention for those of you who probably haven't ever touched Rust before, maybe don't have much experience building blockchain infrastructure or really building smart contracts, but maybe you're more into building user interfaces and user experiences for these blockchains. And so here's a list of ideas. This is just a list of random ideas that come to mind when I think, hey, if I were a developer that is at a hackathon right now, what would it look like if I were to lead a team and I actually have no interest in building anything on the runtime level? What would that look like? Well, here's what it would look like to me, guys. Like, you know, someone leading a project that is taking advantage of Substrate Connect, taking advantage of the fact that there's all these palettes out there that are really cool and have really great, like solid and battle-tested logic, but aren't really getting user adoption. What would that look like? How can I build something that would be incredibly empowering to the runtime developer? So I actually have this. So this is a visualization tool that someone on seminar is going to be presenting next week on Tuesday. Tuesday next week, please be there. Please be there. It'll be really cool to have people from the hackathon. It happens on the 7th. This is a visualization tool that he built very easily because he wanted to make the most of Substrate metadata. Right? What we're looking at here, guys, is just the validation of Kusama's network. I took this video not long ago, today, and basically it's a visualization tool that you're able to go. Actually, if you notice this logo behind me, it's inspired by that, where the developers just wanted to find a way to visualize all of these validators on Kusama and how blocks are being produced in real time. So if you check that out, hopefully it's inspiration. Really, all it is, it's making use of the metadata and the storage changes in real time of a Substrate node. It's all built on an application layer. It's not at all touching runtime code. However, it's a really powerful tool. It's really interesting. It's super cool. It could be an NFT. I don't know. I'll leave it up to you. So, oh yeah, maybe I'll leave this slide up for just a second. There's a QR code at the top. The application is called ChainViz. Is there a question? There's a question, and I'll answer it right now because we are looking at this as a visualization. It's a good coincidence. The question is, Parachains are individual blockchains that run in parallel within the Kusama ecosystem. Is that right? That is partially right, because parachains are individual blockchains that run in parallel within the ecosystem of a relay chain, right? Kusama is a relay chain. Polkadot is a relay chain. There's only 2 relay chains that exist today. In the future, there might be some more. Actually, there is some. There's a project called Edgeware that isn't connected to Polkadot, so it is actually running its own relay chain. The relay chain paradigm really is this shared security for parachains. And to answer your question in a single sentence, parachains are application-specific blockchains that make use of the shared security of a relay chain. Yeah, so yeah, Kusama is a relay chain, but Polkadot is one too. Hope that answered your question. This is the link to seminar. I'm totally shilling seminar. I do this bi-weekly, and literally this is perfect. I kind of try to time this with this hackathon, where this developer, he's going to be stepping through his journey as a front-end developer in the Substrate ecosystem. So please join us. It's always great to have new faces. JJ, you said, what about Shiden? So Shiden is the Kusama. Sorry, Shiden. For those that are wondering why I'm talking about this, it's that JJ in the chat just asked us. So basically, Shiden is the canary network for a star network. Okay, so Polkadot really is a blockchain, is the relay chain that we all know that uses the doc token. But when Polkadot was being developed, before launching Polkadot into production, the first thing that Parity launched is Kusama. And Kusama, the idea behind Kusama is that we needed to have a value-bearing network to test these things, because Polkadot is the sort of very well composed version of the innovations that are coming out of this parachain paradigm, and Kusama is the opportunity to maybe push innovation a little more to the maximum, to really explore things where we're not so worried if things break. However, it's not a testnet. A testnet, remember, has no economic value, because in order to test things correctly, we in order to genuinely test things in a blockchain environment, you actually need economic value to be a part of the equation. Otherwise, you're not really testing in the same way. How do you test behavioral economics, right, without economics? So Kusama is the canary network for Polkadot, and a lot of parachains that connect to Polkadot have followed the same path. A-Star Network is a parachain connected to Polkadot, and A-Star Network has its own canary network that they call Shiden. I hope that answered your question. Okay, developer resources. Start with a node template. There's a front-end template too. Basically, if you go to our developer hub, so that's docs.substrate.io, and you go to the tutorials, you will immediately be immersed into the types of material that to bring you up to speed. So we also have a bunch of tutorials, how-to guides, and the Substrate documentation will teach you things like Extrinsics, or what's the transaction queue look like, and sort of basic things to understand how Substrate is built. We have ways to convert solo chains into parachains. So I strongly advise you to do the Cumulus tutorial to learn how to do that. You can actually connect your chain to Rococo by following that tutorial. And there's a guide to do that as well. Ink is a language that allows you to write smart contracts on a Substrate chain. That's also a phenomenon project that you can build a lot of cool things with by, if you wanted to have a chain with a smart contract, or that execute smart contracts, you could do that too. And now Frontier is a way to connect, to turn in your Substrate blockchain in an Ethereum compatible way. It means if you want to, so Moonbeam is an example of that. There's some bounties that Moonbeam left for this hackathon. I invite you guys to look at that. Literally, Moonbeam is sort of the go-to network to deploy contracts that then can be Ethereum compatible too. That literally means compatible with Ethereum network. So it's not just EVM compatible. There's a difference there. And way more. This gigantic, less beautiful than Justin's QR code is a link to the Hackathon hacker guide. So check the hacker guide. There's so many resources there. They're all there actually. So really, this is kind of redundant. Really, go here and you will have all the information you need. Thank you so much, guys. I went a little over time. We have a session tomorrow about Ink. I forgot to say that. So Ink is the smart contract language. Hernando is going to be giving a session on just different ways that if you're a smart contract developer, maybe you're more familiar with using tools and ways to develop your smart contracts. Well, trust me, working with Ink is actually very, very satisfying and powerful. So that's what you guys should do if you're interested in that. Go to that workshop. Yeah, is there any questions? There's one question here. Okay, so let me see. So what happens when a project, dApp or token, on a Kusama parachain is greenlit for a Polkadot parachain? Yeah, so does everyone stop using it and its value goes down? What happens if a project... Yeah, I'm not sure what you mean. Maybe I think I know what you mean. The question that the way you ask your question reflects maybe some confusion, where really, if you are a parachain on Kusama, you have your own economics, you have your own like market cap. Everything is separate from the parachain on Polkadot. So I hope that answers your question. It's its own thing. There are different markets, completely different. Yeah. Cool, guys. So I think that's all for questions.
So, Sasha, I actually had a question as you were talking through this, and I know today is meant to be focused on Substrate, and we went into some of these details, but I wanted to pick your brain a little bit because we have all of these ecosystem teams now in the hackathon and so on, and roughly, how do you see people getting started with a non-substrate route? And again, I understand today is an introduction to Substrate. You touched also upon the user experience stuff and so on. But I think you've briefly mentioned Moonbeam and Moonriver. They've got EVM compatibility. The workshop tomorrow is Ink, which is also a smart contracting language. So could you maybe just, for the sake of a nice summary and an overview, try to sum up some of these options that developers might have coming into the ecosystem?
Yeah. So yeah, the typical entry point is to understand the runtime paradigm, right? So that's going to be sort of very useful for even the smart contract developer, just to at least kind of know what we're talking about when we talk about like how Substrate is composed, the architecture of Substrate. And now, then you can think of it as you can fork off in different ways from that entry point, right? And one of them could be developing tools. So let's dive in a little bit into that. So let's go into the Parity Tech repo. So one entry point could be that you are more interested in making some sort of CLI that can give you balance updates whenever there's a change in your wallet. You wouldn't be writing a palette to do that, right? You'd probably be using this thing called subxt, which is a way to submit. It's a way to submit extrinsics to a Substrate node, right? And the interesting part in this is that you would actually be completely isolated in the code of that application. You won't be, we can look at some examples. You wouldn't be touching the runtime development. Does that make sense? So that's one way we can think of. What I mean specifically is this is an example of writing a balance transfer using subxt. This library is really powerful because it actually generates a runtime API interface where all you need to worry as an application developer is how you want to interact with it. And it's also super lightweight because it's statically typed. Also, it's all of the types are known at compile time. So this is the thing that comes to mind when I think about like tooling and stuff, right? These different client applications. The other path you could take is the user interfaces path, right? So Polkadot.js API specifies the JavaScript libraries to interact with a Substrate runtime. You wouldn't, in this case, neither would you be looking at the Substrate runtime. You would be building an application. You would need to understand the basics and metadata and how it works. You would need to understand what a state query looks like and what you would sort of how, for example, the storage key is structured in Substrate to know how to basically encode and decode. You need to understand these basics. However, your focus would be on building meaningful user experiences, right? And Substrate Connect falls nicely into that area too, because you'd be making an application that makes use of the light client capabilities of Substrate. I'm going down the list still, Irvin, right? So we're still at this path. We've understood pretty much broadly what we could do with Substrate, which hopefully this talk has given you. And we just talked about maybe tooling. We've just talked about perhaps focusing on user interfaces and experiences. Now, what would it look like if you actually just wanted to dive into runtime development? The very best way, guys, to do this is to clone the Substrate repo. Clone the Substrate repo and look at what already exists in the frame folder. So let's go for a random example, and we're going to look at what the NFT palette looks like. That's actually implemented in StateMine, which is the parachain that handles asset management in the Polkadot ecosystem. So what's it called? It's called Unix palette, right? Yeah. So Unix is here. So the Unix module. So now we're the person that's at the road fork, and we're deep into the okay. Let's do some runtime development here for my application for whatever my submission. So this is just an example of a frame palette, and you can see what I would do to start learning this is to kind of learn by example. Look at how these existing palettes have been built. Right? We have the configuration trait. Has the item ID, so that's the type used to identify a unique item within a collection. By the way, all of this code is incredibly well documented. We have a trait to enable a locking mechanism. I mean, this is a really complex palette. I'm not saying that you should be implementing the same thing. I'm saying that this is a really good starting point to dive into runtime development. So scrolling down here, I'm at line 155. We have the storage items. So you'll quickly learn that in Substrate, when you're developing runtimes, this concept of storage, we could either be storing a map, like a storage map, it's like a hash map, or we could be storing a single value. For example, the single value. So this is storage nmap. I mean, there's no single value map in this palette actually to show you guys. So really, like, I hope that at least just really quick looking at that gives an idea, and then I would dive into making your own palette, right? Looking at all of these palettes that exist, and by the way, these are in production. Like, these have been audited by audit firms, most notably sort of the consensus layer, the staking layer, which is also here. So This is the staking palette. It's very complex. It's really kind of cutting edge Rust and Substrate, but it's a great way to learn from really what the cutting edges, or not even cutting edge, but like the state of the art best practice writing Substrate modules looks like. And so really that covers that last category of NFTs probably, but DeFi, where we're really on the runtime level of making the most of Substrate.
Awesome. More than answered my question. So we did get one more question, and I think this one's more for me, so Justin actually answered this. How can we rewatch this crowdcast? You can actually rewatch it on the same link. It should work. It should take you here. Or go to YouTube. This is actually live streamed to the Polkadot YouTube as well, and it's going to be contained in there. I think you should be able to find it on Angel Hack's YouTube as well. So there's a couple of options. These workshops are all listed on the dev post page under the tab workshops, or you can find them in the hacker guide as well. So we try to keep everything in one place for people that might not be here from the beginning. So just quickly answering that. So I think we are running, we're way past time anyway, but I think if there's no more questions, I'd suggest we just wrap up the session. Final opportunity to ask some questions. Here it is. Anything gonna come in? No? All right, good. Then let's wrap it up. I would love to thank you, Sasha. This was a wonderful, wonderful session. I've personally learned a lot, and I've listened to a few of these versions a couple of times, so this has been truly informative. I hope the audience has learned something as well. We try to keep these sessions light and engaging. So thank you very much for being here, for participating. Justin, you as well. I know it's late for you in Singapore at this point. So thank you very much for being here. I hope to see you again tomorrow. Tomorrow is a session on ink, where Hernando is going to do a really, really cool workshop. I've seen that in person as well, and I think it's fantastic. It's really, really useful. So I hope to see everybody there tomorrow, and that is basically it from us.